Good evening. Today we are continuing with Chapter 6, Lessons 4 through 6. So let's get started. Lesson 4 is on quadratic equations. And the key idea is to keep in mind, quadratic equation can have two solutions. Always start by setting your quadratic equation equal to 0, then proceed to factor. You need to find the values of x that will make each factor equal to 0. Quadratic equations contain a square, for example, x squared minus 3x equals 4. Sometimes you'll see the 4 on the left-hand side, so it would look something like x squared minus 3x plus 4 equals 0, or x squared minus 3x minus 4 equals 0. One way to solve quadratic equations is by factoring, and this is the simplest method, and the one that you would probably be using on the reasoning test. When you factor an expression, you find the terms that divide evenly into that expression. And I should just mention really quickly that there's more than one way of solving a quadratic equation to find its solutions. You can factor, as it mentions here. You can use something called the quadratic formula. You can complete the squares. And then the book also uses a method where you simply just plug in the solution options that are given to you. So in this example, we're asked to factor the expression 15x squared plus 9x. Essentially, you want to look for a term that divides evenly into both 15x squared and 9x. Both terms can be divided by 3x. Why? Because 3 goes into 9 3 times, 3 goes into 15 5 times. You can see that both terms contain at least one x. We have x squared with a coefficient of 15, and then we have x with a coefficient of 9. So the lowest common factor between both of them is 3x. So you want to factor out 3x and then rewrite your quadratic expression in terms of your factor. So since we've decided that 3x goes into 15x squared and into 9x, you would write down 3x, and then in parentheses you would have 5x. Since 3x times 5x would give you your first original term, 15x squared, and then 3x times 3 would give you 9x. And so that's essentially what factoring out means, is finding the lowest common factor between a set of terms. And then you would proceed using any one of the methods I just mentioned, the quadratic formula, or completing the squares, or sometimes you can, if this factored a little bit more evenly, we could have just easily solved for the solution based on the factoring method, but this would require additional steps before finding the solution to x, or in other words, what value x should take on. But at this particular example just wants us to factor, and we've done that simply by looking for the lowest common term that can divide evenly into both terms in our main expression, and that term happens to be 3x. Okay. And you can always, of course, check your answer by multiplying the factor that you found into the simplified expression, and if you get the same original expression, then you know that you're correct. Then you know that your factor is correct. You can factor a quadratic equation to solve it. I just essentially went over that there are 3 different ways to finding what value x should take on, and that's known as solving a quadratic equation. A quadratic equation may have 2 solutions. You want to find values that make the factors equal to 0. Since a number multiplied by 0 is 0, each of the values is a solution. So let's look at some examples. Study this example to learn how to multiply factors with more than one term. So we're asked to multiply the first factor, which is 2x plus 3, by another factor, x minus 4. So anytime you see a set of terms written like this next to each other, refer to them, or they're referred to as factors. So the factors in this particular expression have 4 terms total: 2x, a positive 3, x, and the negative 4. So you want to multiply each, and I should mention that For each term in a factor, you want to refer to the term in terms of, or you want to refer to the term by referencing the sign that is to the left of the term. So this 2x, we automatically assume that when you don't see a sign in front of a term, it's positive, just like in real life, right? Or when you look at your bank statement, whatever number is showing on there, you're not going to see a positive sign next to it, but you automatically know that that number is positive. So this particular term has 1, 2, 3 positive terms, or I should say this particular expression contains 2 factors with 1, 2, 3 positive terms and 1 negative term, okay? So 4 terms total. We want to multiply each term in the first factor by each term in the second factor. And we went over this in the last class. This is called the FOIL method, right? So FOIL meaning first, F in FOIL representing first, the O representing outer, I represents inner, and then L represents last, or your remaining term. First term is 2x, and we're going to multiply that by the first term in the second factor here, and that's x. So 2x times x gives you 2x squared. That's where this 2x squared is coming from. Then you're going to multiply the first term by the outer term, and that happens to be 4. So 2x, excuse me, that's -4. So 2x times the -4 is a -8. That's where this -8 is coming from. Then you move to your inner terms. 3 times x is 3x. And then 3 times 4, we move to our last remaining term, 3 times -4 gives you -12. And I just kind of color-coded what's being multiplied so you can follow through when you're studying. So you can see here, starting with our pink, we know that we multiply the 2 terms connected with the pink line, or whatever you want to call this. So 2x times x gives you 2x squared. 2x times a -4 is -8x. Positive 3 times positive x gives you positive 3x. And then a positive 3 times a -4 gives you -12, okay? And then you want to further simplify this expression, right? We can see that we have 2 like terms here. We have a -x and we have a -8x and we have a positive 3x. When you add those 2 together, you get a -5x. And so this is your simplified expression, which is also called a quadratic form. So this would be the quadratic form, and this 2x plus 3x times x minus 4 would be the factors of this quadratic form. And by factor, we just mean that these are the terms you would have to multiply together in order to get this quadratic expression. Okay. Do you have any questions?
No.
Okay. So I brought this back from the last lecture as a review. The method that we just used in multiplying factors is called the FOIL method. And the letters in FOIL, I've already explained, stand for first, outer, inner, and last. So you want to use the word FOIL to make sure that you've performed all the necessary operations. And this just makes sure that you're multiplying absolutely every term in your factors, that you're not leaving anything out, so that you get to the final and correct quadratic expression. So again, let me zoom in. You're going to start with the first term in your first factor and multiply that first term by the first term in your second factor. Okay, so A times C would give you AC. Then you would go back to your first term and multiply that by the outer term. A times D would give you AD. Then you go back to your first factor, its second term, and multiply that by the first term. And so that's your inner multiplication. You're multiplying the 2 innermost terms by each other, right? B times C, and that would give you BC, whatever that number, whatever that value, or whatever that term is. So it could be a coefficient, it could be a coefficient and a variable. And then finally, you would multiply the second term in your first factor by the last term in your second factor, B times D, and that would give you BD. Okay, and this would be the steps that you would need to take to expand the terms in your factors, in the two factors that you're multiplying together. Trial and error can help you find or can help you factor quadratic equations. The more you practice, the better you will get at solving them. So it might seem like a bit of a process going through this, but I promise the more you practice, the easier it'll get, and you'll automatically know what you need to do once you started with the first term, and then move over to the outer. And basically, you're just essentially playing a matching game and making sure that each of the terms in your two factors are multiplied together. Here, this example is asking us to solve x squared minus 3 equals 4. So the first thing you want to do is set your quadratic expression to 0 by subtracting 4 from both sides of the equation. So if we subtract 4 from the right-hand side, 4 minus 4 is 0. And if we subtract 4 from the left-hand side, we'll be left with this expression right here, x squared minus 3x minus 4. Here's our 4 that we're subtracting from the left-hand side. Or as I just like to think about it, or this is how I was taught, anytime you see a quadratic expression with a coefficient on the right-hand side, you immediately want to get rid of that coefficient so that it can be easier for you to then continue with whatever steps that you need to take to solve for x, right? So the first thing you want to do is set this equation to 0. And so you would just move whatever coefficient is on the right-hand side over the equal sign. And anytime you move something over the equal sign, it changes sign. So we started with a positive 4. We move that positive 4 over the equal sign to the left-hand side. And so that's going to change the sign of that positive 4 to a negative 4. And so we immediately have our expression that we can then proceed to factor. So by trial and error, the factors of this expression, or well, let's go in the order that the book is presenting the information so that it's a little bit easier to understand. I was just going to jump to the answer. The book is asking you to think what factors of the last term, and this is our last term, negative 4, when added together would give you negative 3. Well, we know that if we added a positive 1 to negative 4, that would give us negative 3, right? So knowing that, then our factors are a positive 1 and negative 4. When I say positive 1 and negative 4, if you recall, your factors should take on this form, right? So x would be here, we would have plus 1 and then x minus 4. And if you multiply those two terms together, you would get this. You would get this expression right here. So yeah, if either one of the factors equals 0, then the product of the terms will be 0. You want to set that factor equal to 0 and then solve for x. So that's what this is telling you right here, that once you've identified what your factors are, you want to set them equal to 0 and then solve for x. So you would start off by writing your factors with empty spots for where the terms that you figured out need to go. And then we've already set the expression equal to 0, and then you would just proceed by solving each individual. You would proceed to solve each individual factor by setting them both to 0. Okay, and that's what this note or this third step is telling you. So by induction, or just by looking at our expression, if we added positive 1 to negative 4, it will give us negative 3. So we know that positive 1 is our first factor, right? So here, once you've written out your parentheses and you've added your x term, you know that the next number or the next term that should go in one of your factors, and again, the expressions in brackets are our factors, right? So you know that the first term that should go in one of your factors is positive 1, based on what we figured out here, that when you add 1 to negative 4, it'll give us negative 3, right? So we're going to put positive 1 in our first factor, and then we know that negative 4 should go in the second factor. And then you simply just want to set the two factors equal to 0, as this third step is telling us, and then solve for x. So x plus 1 equals 0. To solve for x, you want to isolate it. And to do that, you can move this coefficient over the equal sign. And as I mentioned earlier, anytime you move a number over the equal sign, it changes signs. We're left with x on the left-hand side and a -1 on the right-hand side. Or you can think of it as just subtracting 1 from both sides of the equation. So 1 minus 1 on the side would give us x plus 0. So you would just write down your x. And then since we're subtracting 1, 0 minus 1 leaves us with -1. So x equals -1. Then you would do the same thing for your second factor. You'd set the second factor equal to 0, and then you would either just move the 4 over the equal sign to give you a +4, or you can think of it as adding 4, because to get rid of this 4, you would need to add 4. You can think of it as adding 4 to both sides of the equation. So -4 plus 4 would leave you with x plus 0. So you write down x on the side, and then 0 plus 4 leaves you with 4 on the right-hand side. So the solutions for this quadratic expression are -1 and 4, right? But most quadratic equations aren't this straightforward. I think probably the ones on your reasoning test, you can probably approach them as we did here, and then you would just proceed as we've done here. But most of the time you're using, well, let me not go there because there's no point. It's not mentioned in the book. All right, so do you have any questions, by the way?
No, I was lost for a second, but then I was like, oh, okay, I get it. I got it.
Do you want me to do this over?
No. I confused myself. I got it.
Okay, so just really quickly, the things to keep in mind is that you want to start by setting your expression to 0, okay? So that's what we've done here. So to set this to 0, you have to move the 4 over the equal sign. Or there are two ways to do that, right? You can simply just move the 4 over the equal sign. You know that it changes its sign and it's going to now become a -4. Or you can just subtract 4 from both sides. I don't remember what chapter it was on, but this is something that we've covered in terms of whatever you do to the right-hand side, you want to do to the left-hand side, right? So to set for the right-hand side to be equal to 0, we need to subtract 4 from the right-hand side. Okay, and since we subtract 4 from the right-hand side, we would then go ahead and subtract 4 from the left-hand side. Okay, so on the right-hand side, we have 0, and then on the left-hand side, we show that we've done the same thing by showing a -4 here on the left-hand side. All right, so that's the first step you want to take to solve for x. X here represents some number that we don't know, right? And so the goal is to solve for x. And by solving for x, we're trying to find the numerical value that we can plug into this expression to make it true, right? And so those values would be the solution of our quadratic expression. This is our quadratic expression. So on your test, if it tells you to find the solution of the quadratic expression, x squared minus 3x equals 4, it's simply telling you to find the value of x such that when you plug it into this expression, it will be true. In other words, let me fast forward to what we did. So we did all the necessary steps and we figured that the solution for x can either be -1 or 4. Remember that in our it's this note. It tells you that you factor a quadratic equation to solve it, okay? And by solving it, you're simply just finding whatever value x should be. And a quadratic equation may have two solutions, okay? Sometimes it only has one solution, but sometimes it can have two solutions. And here we find that there are two solutions to x, or there are two values that x can take on to make this quadratic expression true. The first one is -1, so let's test it. if we plug in -1 into x, -1 squared is 1. 3 times -3 times -1 is +3. 1 plus 3 equals 4, right? So we know that -1 is a true solution of this expression y, because when we plug in -1, we get 4 for real, right? If we went to this expanded form of the expression, we plugged in -1, we would have -1 squared. -1 squared is 1. -3 times -1 gives you +3. Remember our lesson on signs, we know that when we multiply two negative numbers by each other, we get a positive number. So -3 times -1 would give you +3. 1 plus 3 is 4. 4 minus 4 is 0. Okay, so we found, or we verified our first solution. Let's try the second one, which we found out was 4. If we plug in 4 here, 4 squared is 16. 3 times 4 is 12. 16 minus 12 is 4, right? And we can also test the expanded form of our expression. 4 squared is 16. 3 times 4 is 12. 16 minus 12 is 4. 4 minus 4 is 0. Okay, so essentially, all you're doing when you see a quadratic expression, don't freak out. Okay, it's really very simple. All you're doing is trying to find out what value of x would make this expression true. That's why it's like it's a mystery. We don't know what it is, right? So we're going to solve for it. So that's all this is telling you. Solve x squared minus 3x equals 4. Simply just means find out what value of x you would plug into this expression to make it true, right? And from the note that we just read earlier, we know that some quadratic equations can have one solution, some can have multiple solutions, right? There could be multiple numbers that you could plug in here that would give you this value of 4. But from the process that we found out, we know for sure that there are two numbers. There are two such numbers, I should say. The first is -1 and the other is 4, okay? And so you already understand that to continue with the steps required to find x, you would want to start by setting this equation equal to 0. Why? Because earlier I showed you that when you plug in -1 and -4 into this expression, it equals 4. And when you plug in those two solutions into this particular expression, you would also get 0. So in other words, this expression x squared minus 3x equals 4 is mathematically equivalent, or is mathematically the same thing as x squared minus 3x minus 4 equals 0. Why? Because all we did was simply move 4 over the equal sign, or we subtracted 4 from the right-hand side. And so you know that if you subtract 4 from the right-hand side, you need to do the same thing on the left-hand side. So let's give you a simpler example. Let's say the expression on this left-hand side was 5, okay? And the expression on the right-hand side was, and the term on the right-hand side was also 5, essentially telling you that 5 is equal to 5. You're like, okay, cool. 5 is 5, that makes sense. If you subtract 5 from this side, 5 minus 5 is 0. 5 is no longer equal to 5 because now we have 5 on the left-hand side and 0 on the right-hand side because we subtracted 5. So to make this expression equal again, since we subtracted 5 from the right-hand side, we would need to subtract 5 from the left-hand side. So then 5 minus 5 on the left-hand side is equal to 0. 5 minus 5 on the right-hand side is equal to 0. And now again, we have a mathematical equivalency, 0 equals 0, right? And so we carry on that basic principle onto whatever expression that we have. This is no longer 5 equals 5. It's now x squared minus 3x equals 4. but you know that you can plug in some number into this expression to give you a coefficient or one whole number on the left-hand side, and that number has to make the expression x squared minus 3x equal 4, right? What number is that? We don't know. Well, we can figure it out. So our first step is to make sure that we establish what? A mathematical equivalency. And we can do that simply by moving 4 over to the left-hand side or subtracting 4. If we subtract 4 from the right-hand side, we need to do the same thing on the left-hand side so that, again, we have mathematical equivalency, or we're writing the same equation in two different ways, okay? So these two equations are exactly the same, they're just written differently. And they're written this way so that it's easier for us to figure out our solution. Why? Because this step here tells you that to figure out what x is, you need to use trial and error. Well, in order for you to be able to use trial and error, you need to look at two terms and figure out, okay, here, my last term, my last number, what could I have possibly done to get -3? And in this particular instance, if you add +1 to -4, it would give you -3, right? So essentially, we are just working backwards to find what number x should be, okay? And there are two possibilities for x, as we figured out. The first one is 4, and then the second solution is a -1, because we know that if we add a -1 to -4, we'll get -3, which is our middle term here, okay? And so your -1 and your -4, which you figured out by just looking at this expression. And that's why it was important for us to move the 4 over so that we could figure out the solution for x. Then you can proceed to plug in the factors that you found to find what x is. Just know that when you're solving for x, and actually I had it in here, but then I removed it because I felt like it would complicate the lesson. And now I wish I would have left it in there. I had the conventional steps, but just know that the book essentially.
Oh, okay. I get it though. Yeah, I'm
Okay.
following along.
Okay. Okay, good. I think with more exercises, it will get clearer. So let's continue with lesson 5, which is on algebra problem solving. Essentially the same thing that we were just doing now. You can use guess and check as a strategy for answering complicated multiple choice questions. Choose an answer from the options and then try the value in the problem. If it works, you found the correct answer. And again, the book is providing you with the answer, skipping steps that you would need to get to the solutions. I guess it's just a way of making this information a little bit easier. So one strategy that can help you save time on more complicated algebra problems is guess and check. Guess and check means selecting one of the answer choices and then trying that value in the problem. So in this instance, the answer choices are in the multiple choice. So if you guess correctly, you can just move on to the next question. If not, just guess again. Guess and check is a good strategy for problems involving quadratic equations and expressions. So here, we're going to use the guess and check method to find which of the following is a solution for this particular quadratic equation. We have 2x squared minus 12 equals 2x. To solve this problem, you would have to rewrite the equation so that the quadratic expression equals 0, and then factor the expression and solve, which is what we did in the previous example. But the book is telling you that instead you can use guess and check method, which just involves substituting the options that you're given, because at the end of the day, solving a quadratic expression just means finding the value that x should take on to make this expression true. And since they've already kind of figured it out and they're telling you to choose, well, why not just check, right? So let's start with the first option, which is 4. If we plug in 4 into this original expression, 2 times 4 squared is 16. 2 times 16 is 32. 32 minus 12 is 20. 2 times 4 is 8. So we already know that this is not true because the left-hand side does not equal to the right-hand side. So we go on to the next expression, the next solution rather, which is 3. Let's plug in 3 here. 3 squared is 9. 9 times 2 is 18. 18 minus 12 is 6. 2 times 3 is 6. 6 equals 6. We have 6 on both sides, so we know that 3 is the correct solution for this expression. So essentially, all we've done is just test out the solutions to see which one gives us the same number on both sides of the equal sign. Here's a test tip. You want to use your judgment, not use guess and check if you can quickly see how to solve the problem. Trying each answer choice may take longer than simply just solving the problem. And I think I mentioned this in Thursday's lesson because there was a similar scenario. So in this example, we're told that Terry is 10 years older than his brother Thomas. 20 years ago, Terry was twice as old as Thomas. How old is Terry now? So this is an example where you would need to write out a quadratic equation to solve this, right? And I showed how to do that in the last lesson. But here the book is telling you that sometimes just try each answer problem, but know that it may take longer. So it may take longer than simply solving the problem. Instead of writing an equation, try each age in the answer choices. So choice A is 25. So that means that Terry is now 25 years old. And that implies that Thomas is 15. Since Terry is always 10 years older than Thomas, 25 minus 15 is 10. So this means that 20 years ago, Terry would have been 25 minus 20, he would have been 5 years old. So now if we take Thomas's age of 15 and we subtract that from 20, we would get -5, right? So no one is -5 years old. That means that Terry must not have been born 20 years ago. So 25 cannot be the right answer. So let's try the second choice. 30 simply means that right now, Terry's age is 30. So since they are 10 years apart, that would mean that Thomas is 20 right now. Terry's current age, 30 minus 20 is 10. And Thomas would have to be 0 years old because if you subtract 20 minus the number of years that we're going backwards, which is also 20, 20 minus 20 is 0. 30 is the current age of Terry. If we subtract 30 from 20, the number of years that we're going backwards, Terry would be 10 in the past. And if we subtract 20 from Thomas's current age, 20 minus 20 would give us 0. And we got 20 because we know that Terry is always 10 years older than Thomas, right? So if Terry is 30 right now and we subtract 10, that makes Thomas 20. And so if we went back in time for Thomas, since he's 20 years old now, if we go back in time 20 years, he would be 0 years old. So he would be an infant. And with Terry's current age of 30, if we go back 20 years, he would have been 10 years old. And again, we're looking for an age where Terry was twice as old as Thomas. So A is not true and B is not true. We go on to C, and the age is 40. C means that Terry is now present day 40 years old, which would make Thomas 30. Why? Because they're 10 years apart, right? As the question tells us, Terry is 10 years older than his brother Thomas. So if Terry is currently 40 years old and he's 10 years older than his brother Thomas, then that makes Thomas 30. So if we go back in time 20 years, for Terry, 40 minus 20, 20 years ago, if he's 40 years old today, 20 years ago, Terry would have been 20 years old, right? Because 40 minus 20 is 20. And Thomas, who's 30, if we go back in time 20 years, 30 minus 20 is 10. So 20 years ago, if Terry is 40 today and Thomas is 30 today, 20 years ago, Terry would be 20 years old and Thomas would be 10 years old. And 20 is twice 10, or 10 times 2. So 40 is the right answer here. And again, you're just simply, if it's easier, you can maybe use yourself and maybe your mom as an example. So whatever age your mom is today, whatever age you are today, right? If you had to go back in time 20 years, what age would your mom have to be twice as old as you are? That's what this question is telling you. Terry is 10 years older than his brother Thomas. 20 years ago, Terry was twice as old as Thomas. How old is Terry now? So let's switch this around to make this easier to understand. Lisa's mom is 10 years older than Lisa. 20 years ago, Lisa's mom was twice as old as Lisa. How old is Lisa's mom now? Okay, so then you would just, instead of specifying an equation, you can simply just look at the answer choices, okay? So let's say Lisa's mom was 25. Since we know that Lisa's mom is 10 years older than Lisa, if Lisa's mom is 25, that would make Lisa what? 15, right? Since she's 10 years older, 25 minus 10 is 15. So now we know Lisa's age. So now that we know Lisa's mom age, which is 25, and we know Lisa's age, which is 15, let's go back in time 20 years, okay? How old would Lisa's mom and Lisa be 20 years ago? 20 years ago, 25 minus 20, Lisa's mom would have been 5 years old. And since we know that Lisa's 15, 15 minus 20 is -5. That means Lisa wouldn't have been born, right? That's essentially what we were doing here. And I don't know if it was clearer, but I think that maybe putting your name in there, making it more personal, makes it less muddy. So if we go to our second answer choice, today, Lisa's mom is 30 years old. So if Lisa's mom is 30 years old today, and we know from the question that says mom is 10 years older than Lisa, what does that make Lisa? 20. So Lisa's mom is 30, Lisa's 20. Let's go back in time 20 years. 20 years ago, Lisa's mom would be 30 minus 20, or 10 years old. And 20 years ago, Lisa would be 20 minus 20, or 0 years old. Lisa would have been an infant, right? And 10 is not twice of 0, right? So we know that this choice is not correct. So let's try the third choice. Today, Lisa's mom is 40 years old. So let's figure out Lisa's age. We know from the question that Lisa's mom is 10 years older than Lisa. So 40 minus 30 would, 40 minus 10 gives us 30, which is Lisa's age. So essentially, when Lisa's mom is 40, so that means Lisa's 30 based on the information that we have, right? So now that we know Lisa's mom is 40 and Lisa is 30 based on the information that we have, 40 minus 10 is 30. Let's go back in time 20 years. 20 years ago, Lisa's mom would have been 40 minus 20, which is 20. So she would have been 20 years old. And Lisa would have been 30 minus 20, or 10 years old. And so 40 years ago, Lisa's mom would have been twice as old as Lisa. Why? Because Lisa's mom would have been 20 and Lisa would have been 10. So I think it was one of the earlier lectures where I was telling you that with word problems, if it sounds confusing, a lot of the times when you make it personal, then it makes it a whole lot easier to see what's going on, right? And you could, if you wanted to double check, you could apply the same logic to the last question, right? The last solution. So if your mom is 45 today, that would mean that you were what? 45 minus 10, 35, right? So let's go back in time 20 years. 45 minus 20 is 25, and then 35 minus 20 is 15, and 25 is not twice 15. So we know that this answer choice is wrong. We already found our right answer, but I just wanted to do this last one again to just kind of drive home what we were doing, right? We're just basically working backwards to figure out what X, or what the solution should be. And that's essentially what these quadratic equations are. They're a mathematical representation of statements like this. Last lecture, I went over a few examples of that. More practice exercises starting on page 961 to 964. And then the final lesson is on coordinate planes. The coordinate grid is formed by two intersecting axes or number lines. The x-axis is horizontal and the y-axis is vertical. The location of a point is shown by two numbers called an ordered pair or the coordinate. If you've ever used the share my location feature in your iPhone, that's essentially what it's doing, is using coordinates to locate where you are on the map. A more complex system, of course, but the basic idea is right here. Imagine that this was some sort of map and this is where you are and your friend is in this city, okay? And this origin, you can consider it the starting point. So maybe you started here and moved to this location. Your friend also started here and moved to this location. So M is your friend's coordinate location, or the ordered pair that we would need to find on a coordinate plane. This is a coordinate plane with two axes, your y-axis being vertical, your x-axis being horizontal. So we would need to find the ordered pair for M to locate your friend, and we would also need to find the ordered pair for P to locate you, since you both started at the same point. This point right here, 0, 0 on the coordinate plane, is known as the origin, okay? So a coordinate grid is a way to locate points that lie in a plane or a flat surface. The grid is formed by two intersecting lines, an x-axis, which is this horizontal line right here. So the way I would remember this when I was learning is that when you're at the ocean and you're looking into the distance, you're looking into the horizon and it's flat. That's your horizontal line, your x-axis, right? And then the vertical axis by default is the y, is your y-axis. So the x-axis is actually a horizontal number line, okay? And the y-axis is a vertical number line. The point at which the two axes intersect is called the origin. So each point on the grid can be named using two numbers called an ordered pair. The first number is the distance from the origin along the x-axis, and then the second number is the distance from the origin along the y-axis. The numbers are written in parentheses and separated by a comma. So it would look something like this, x comma y, okay? So anytime, okay, let's just do this example first before I make that comment. So write the ordered pair for the points M and P. So let's go back to our earlier scenario where this is your friend. She's located at point M and you are here at point P. So anytime you want to find the coordinates of a point, you always begin at the origin, okay? And then you always want to start with the x-axis first and then the y-axis. The reason is it's a universal standard. So that means that if you told somebody in Russia that your friend is at point 2, 3, they will know to begin on the x-axis and move 2 steps to the right. And then, so 2 is the value for x, and then 3 steps upwards, 3 being the value for y. If you had told somebody in Russia that your friend is at 0.23 and they started and went 2 steps up the y-axis and then 3 steps on the x-axis, they wouldn't be able to find your friend, right? So it's just essentially a standardized way of presenting information about a coordinate. You always want to start with the x value first and then the y value. And then anyone anywhere will always find the same location. We've already determined that point M lies 2 spaces to the right of the origin, 1, 2. So if we count 2 spaces to the right, 1, 2, and then count upwards from 2, 1, 2, 3, we found your friend. She's at point 2, comma 3. So that's the coordinate location for X. And then if we want to find U, we would do what? We would start on the x-axis first, and we would, this time around, since you're on this side, we have to move leftwards on the x-axis. So we have to move one step to the left. That means -1, since we're on the left side of the x-axis. And then we have to move 3 steps downwards. 1, 2, 3, -3. So we can report that Elisa is at location -1, -3 on the coordinate plane. And again, we did that by counting, or let's read the note given to us by the book. Point P lies 1 space to the left along the x-axis, okay, and 3 spaces down along the y-axis. Pay attention to the signs. Whenever you're moving right and up, your coordinates will be positive. So your x coordinate would be positive, I should say, and since you move upwards, your y coordinate would also be positive. If M was on this side, you would have to move to the right, positive, and then downwards. So your y coordinate would be negative. Here, we've already established that we have to move both left and down, so our x and y coordinates are negative. And you can just use the information on the plane. You can see that you moved to this spot, -1, and then from this spot, we moved downwards, and the corresponding point is -3. If you had been somewhere here, we would have had to move left. Let's say you were at this point where it reads origin, we would have had to move 1, 2 spaces to the left, and then 1, 2, 3, let's just call this 3 spaces upwards. So your coordinate location, if you were standing here, would have been -2, 3. +3, right, since we moved upwards. To plot points on the grid, you want to use the number lines located on the axes. Remember that right and up are directions for positive numbers, and left and down are directions for negative numbers. In this example, we're told that point A is located at -2, 1, and point B is located at 3, -2. Plot these points on the coordinate grid. Let's find point A first, and based on the information established earlier or discussed earlier, the value that you read first is the value on your x-axis, right? So we go to our x-axis and we locate -2, which is right here. And then the second value obviously is your y, and it's 1. And since it's positive, that means we're moving upwards on the y-axis. So we're moving -2 spaces on the x-axis and 1 positive space on the y-axis. And so this is A. And then we need to find point B, which is located at 3, -2. So again, we're going to start with the x-axis first, and we're going to count 3 spaces to the right on the x-axis. And since it's positive, we're moving to the right. And then the coordinate, the location or the point for y is -2. So we're going to move 2 spaces down. And so we've located our E coordinate, if you will, at 3, -2. Okay. So you always want to start at the origin and then count 2 spaces to the left along the x-axis and 1 space upwards. So we've already established that this is where point A is. And then to find point B, you want to start at the origin and count 3 spaces to the right and 2 spaces down. Okay, so things to keep in mind. You always want to start at the origin, okay? And then the first value that you read is going to be your x coordinate. If it's positive, you're going to move right. If it's negative, you're going to move left. And then once you located your x, you can then proceed to locate y. If it's positive, you move upwards. If it's negative, you move, if y is negative, you move downwards. If it's positive, you move upwards. If you are given a coordinate grid that is not labeled, remember that the origin is at 0, 0. Starting at the origin, count either right or left first, and then up or down. So for example, if you were given a coordinate location that's 0, 3, You start at your origin, and 0 just means you're not moving on the x-axis at all. And then 3, you would move 3 spots up the y-axis, so this would be your point 0, 3. If the coordinates read 0, -3, again, you start at the origin. You're not moving any points or any number of places on the x-axis, since the first coordinate point is 0, and then you would just simply move -3 spots downwards. If your coordinates read 3, 0, 3, 0, then you know that you're starting at your origin, you're going to move 3 spaces to the right, and then since y is 0, we're not moving upwards or downwards, so this would be the location for 3, 0. If the coordinates read -3, 0, again, you would start at your origin, you would move -3 points over, and since y is 0, we stop right here, and this would be the location -3, 0. I just thought of that since, because I saw 0, 0, remembered that sometimes your coordinate points can include 0, and that just means that wherever the 0 is, you're not moving on that axis. So if the 0 was on the x position, you're not moving on x. If the 0 is on y, you're not moving on y. If the 0 is in both locations, then you know that you're at the origin, 0, 0. Okay. More practice problems starting on page 967. And that's essentially it for today's lesson. If you have any questions, definitely let me know. Okay.
Okay.
Or reach out to the tutor as well. I think she sent
No
me.
problem.
Yeah.
Yeah, I seen that she sent me a message. Yeah.
Yeah, okay. All right, cool. See you on Tuesday.